Hello, welcome to Adjacency channel. In this video, we will talk about the OSPF neighbor and adjacency. OSPF neighbor and adjacency are two important concepts. However, it is very easy to be confused by these two concepts. For now, you just think about adjacency equals neighbor plus. Let's talk about the OSPF neighbor first. OSPF routers that share a common segment are eligible to become the neighbors on that segment. Neighbors are elected via the Hello protocol. Multicast Hello packets are sent periodically out of each interface using a multicast IP address 224.0.0.5. Routers become neighbor as soon as they see themselves listed in the neighbor's Hello packet. This way ensures the two-way communications. Neighbors negotiations applies to primary address only. Secondary address can be configured on an interface with the restrictions that they have to be the same areas as the primary address. Let's explain this. So the diagram here is R1 connects R2. R1 sends the hello packet out to the R2. In the R1's hello packet, the R1's router ID is contained in. When R2 receives R1's hello packet, he will get the R1's router ID. When R2 sends his hello packet out to R1, R2 will put R1's router ID, which he just received from the hello packet, into the field of the neighbor of the hello packet, then sends this hello packet out to the R1. When R1 receives this hello packet, R1 checks the hello packet, the neighbor field. If R1 sees the neighbor field of hello packet have his router ID, so R1 know R2 is his neighbor for sure. So now let's talk about the OSPF adjacencies. Adjacencies is the next step of the neighboring process. Adjacency routers are routers that go beyond a simple hello exchange and proceed in the database exchange process. The database exchange process involves the package includes DBD package, LSR package, LSU package, and LS acknowledgement package. Neighboring process just exchange the hello packets. Adjacency building process exchange the OSPF protocol all type of packets. There is a procedure to building adjacency. I have to mention here below. So before two routers form the adjacency, below parameters in hello packet must be agreed on. So area ID, subnet mask, and subnet authentication type and authentication password, hello interval and data interval, area type, all those parameters have to be matched. Here I have to mention, in the best practice, the two routers configured as a OSPF neighbor, the network type on the interface, which is that router connects on a common subnet, have to be same. However, it's good to know the network type information is not in hello packet. There is no requirement for the network type on the interface of two routers attached to a common subnet need to be same. So that means if one side is broadcast type, other side is point type, the two routers can form the adjacency. Since the hello interval for the broadcast type and point type are same. So here I just mentioned this. However, in the real world, the best practice, you need to put the network type so you need to put the same network type for the two routers when you configure the OSPF. The high-level description was a process for building adjacency in multi-access network. On the multi-access network, due to the exchange of hello packets, one router is elected as a DR, another is elected as a BDR. Each router on the segment will establish adjacency with the DR and BDR. All routers on this multi-access segment are neighbors of each other. However, the adjacency relationship is only from the DR or BDR to every routers. This diagram below illustrates this. Left-hand side diagram to show 5 routers connect to a multi-access segment. Right-hand side showing the DR and BDR is elected and the adjacency between the every router to DR and BDR. So, process to building adjacencies in point-to-point network. Two routers on both ends of the point-to-point network exchange the OSPF hello packets, then exchange updated information and form the adjacency. No DR and BDR needed. The OSPF adjacency forming is quicker on the point-to-point link than on the multi-access link, since no DR and BDR election. Purpose of the DR and BDR. People may ask why we need a DR and BDR in the multi-access network. So for the multi-access segment, during the adjacency building process, to minimize the amount of information exchange on a particularly multi-access subnet, OSPF elects one router to be the designated router and one router to be a backup designated routers on each multi-access segment. The BDR is a backup mechanism in case the DR goes down. Instead, each router exchange update with every other routers on the segment. Every router exchanges information with DR and BDR. DR and BDR relay the information to everybody else. The idea behind this is that router has a central point contact for information exchange on multi-access segment. The DR and the BDR exchange information with each other as well. This way cuts the information exchange on the multi-access segment. The below diagram in the left-hand side shows if the routers exchange information to every other routers, there will be a lot of information have been changed. As the blue arrow shows, the right-hand diagram is show if the DR and the BDR is elected, then exchange will be reduced. So as the blue arrow shows, also the DR and the BDR is a central point contact for information exchange. So how to elect the DR and BDR on a multi-access segment? So DR and BDR election is done via the hello packet. Hello packets are exchanged via the IP multicast package on that particularly multi-access segment. On each multi-access segment, the router with the highest OSPF priority on the interface that is attached to the segment will become the DR for this multi-access segment. The router with the second highest OSPF priority on the interface that is attached to that segment will become the BDR. In case of a tie, the router with the highest router ID will win. Other routers that are not elected as DR or BDR in a particularly multi-access segment will be the DR other. OSPF priority is configured on the router interface. The default for OSPF priority on an interface is 1. The priority value of 0 indicates an interface that is not to be elected as a DR or BDR. The states of the interface with the priority 0 will be the DR other. So in the top right-hand corner, I show a small diagram. At least I put the priorities under each interface. So the DR and the BDR elections is based on the priority on the router's interface that's attached to the multi-access network. So the last we talk about the stage of forming the full state of the OSPF adjacency. So adjacency build process take multiple stages. Router that become adjacency will have the exactly linked state database for the area that the interface belongs. The following is brief summary of the states an interface passes through before become adjacency to other routers. So in my right-hand side, I list each state, right? So let's go through every state. The first state called the down state, since no information has been received from anybody on this segment. For example, if there's 2 routers connect, if R1 didn't receive anything from this R2, this R1's OSPF stage will be in the down stage. So next stage is init. The interface has detected hello packet come from a neighbor, but bi-directional communication have not yet been established. So in that stage, let's just see the router just received the hello packet, but didn't see his router ID in the neighbor list is a hello packet. So next state is a two-way state. This is a bi-directional communications with a neighbor. A router has seen himself in the hello packet come from neighbor. So here is the hello packet exchange. So at the end of this state, so the DR and the BDR election had been done for the multi-access network. Routers will decide whether to proceed in building adjacency or not. For the multi-access network, router will build adjacency with DR and BDR. DR other to DR other will stay at two-way state and not proceed to building adjacency. For the point-to-point network, 2 routers will proceed to building adjacency. So the next stage called EX start. So router are trying to establish an initial sequence number that is going to be used in the information exchange packet. The sequence number ensures that the router always gets the most recent information. One router will become the master and the other one will become the slave. The master router will pull the slave for information. This is a database describe packet exchange. So next stage called exchange. So router will describe their entire link state database by sending a database description packet. This stage also is database description packet exchange. So next stage is a loading stage. At this stage, the router finalize the information exchange. router have built a link state request list and the link state retransmission list. Only information that looks incomplete or outdated will be put on the request list. Only update that is sent will be put on the retransmission list until it gets acknowledgement. So in that stage, actually, the link state update first flooded. Then after link update state flooded, if they still have the incomplete information, the router will send the link state request, and his neighbor will respond to this link state request by sending a link state update. So after this done, everything, the router will go to the final stage. That's called the full stage. At this stage, adjacency is complete. The neighboring router are fully adjacent. Adjacent router will have the same link state base for the areas that the interface be passed to. So I think this is the end of this videos. Hopefully, for now, we clear about the OSPF neighbors and adjacency, and different with the OSPF adjacency and neighbors, and what is the states of the full states of the OSPF adjacency. Hopefully this video is helpful. If you like this video, please give a thumb up. Thank you for watching.